start. First thing, we're independent manufacturers. My company, you met the folks from Warner earlier. They're like wholesalers. We're manufacturers reps, so our role is a little different than theirs in that I represent about 60 different lighting manufacturers, lighting and controls manufacturers. We're independent. We don't work for them. We're simply under contract with them. And our role really is to interface. We're the interface between all of those manufacturers and the market. So whether that interface is between them and the distributor or the contractor or the engineer or the architect, our role is to be in that spot between. So we have to know a whole lot about a whole lot. We also have to know what all players are and all the games that get played and all of those things. That's our job to figure out. And for that, if we actually sell something, they pay us something. So it's an interesting role. I've done this for about 25 years now with this firm. And it's an interesting side of the business. You get to see a lot and learn a lot because you're actually touching all the different aspects of the project, including interfacing with the architects. We were joking a little bit about budget and how budgets work. We're involved quite heavily with that. It isn't unusual for myself to get involved with an architect or an engineer or lighting designer at budget and be doing budgeting on a project that probably won't bid for 12 months, 18 months, probably not going to ship a light fixture for 2 years, 2.5 years. It's a real long sales cycle. So when I said you have to know everybody, you have to know everybody. You have to be friends with the entire industry. Controls to themselves really aren't that mysterious. We'll start with some of the real basics. Occupancy sensor, right? The most simple lighting control system out there. Occupancy sensors, people will call them low voltage. It's really, this piece is low voltage, but it gets fed from a power pack that sits up on the ceiling. So you've got a switch drop, power pack in the ceiling, a couple of low voltage conductors come over to this, we stick this up on the ceiling, and we turn lights off and on, okay? Technology is pretty simple. It's PIR as a primary, and then ultrasonic or microphonics. There's a couple of different secondary technologies people use to keep the lights on. The sensor only turns lights on via PIR. So whether you're using a microphone, whether you're making noise or listening for noise, that can't do anything but hold the lights on. It won't turn the lights on. That's important so we don't get false trips, right? So the thing that sees you is the PIR coming out of the facets, and typically then we have to avoid doorways and things like that. When sensors first came out, the industry, like most industries, gets very particular and specific about what their wants and needs are. You know, we're going to turn the lights on when anybody steps, in through the threshold by 3 feet, and that became the magic number. It had to be by 3 feet. I don't know why. I don't think it makes any sense at all, personally. The flaw in the system with an aux sensor is, as these were designed and as they were used for years and years, the only interface that we had for it was a line voltage switch. Okay, so now I've got the sensor on the ceiling and I've got a pair of line voltage switches or whatever I've got on the wall, doesn't matter, single switch, double switch, 3 switches, whatever. The flaw in the system was it was all dependent on the location of the switch, the position of the switch. If the switch was closed and you walked into the room, the lights turned on. If the switch was open and you walked into the room, the lights didn't turn on. That's pretty stupid, right? Doesn't make any sense. Never made sense to me that I would turn lights on in a room just simply because I walked in the room. Right? To me, it was a design flaw out of the box, but it's what the industry did for years and years, and it's not unusual to see it even still specified that way, right? So if you think of a series of in a clinic exam rooms, right? Dependent on the switch position, I can walk into one room and the lights don't turn on, and I walk into the next room and the lights do turn on, and the owner says, why do they do that? Well, because that's how they were designed, unfortunately. You can go around that and not have a switch in place at all, in which case this works all the time. Every time I walk in the room, the lights turn on. Every time I leave, the lights turn off, and you can set time out and all that neat stuff. The smartest solution to that was to use this same device, a power pack that would take a momentary contact and a momentary contact switch. Okay. What this did is make this, rather than an occupancy sensor, a vacancy sensor. The device still sees me, right? I can put auxiliary contacts on this so I can tie it to a VAV or whatever. So If I'm in the room and I want the lights off for whatever reason, but I'm still occupying the room, I can have contacts and I can turn the air on and make sure the air all works. What this guarantees is that I never turn the lights on unless I want the lights on. Lights always go off automatically, or I can turn them off, okay? So if I want the lights off, I can turn them off by switch. If I leave and I've got the sensor set at a 5-minute timeout or 10-minute timeout, in 10 minutes it's going to shut off. When I walk back in the room, regardless of what I've done to the switch, the lights are not going to come on. If I walked in here to drop something off and I have plenty of light because there's windows in the room, I don't need the lights to turn on and stay on for 10 minutes. That scenario drives all kinds of funky behavior. We had actually developed a whole series of secondary ballasts called program rapid start ballasts to be able to handle the constant switching back and forth of that fluorescent fixture. Right? It didn't make a lot of sense. So California now mandates the setup I was just talking about, the secondary setup where the sensor is always a vacancy sensor. Can't ever turn the lights on unless I want them on. We've assumed everybody to be smart enough to know that when they walk into a room and it's too dark to see, that they'll turn the switch on. We've kind of all been conditioned to do that since, right? So, very simplest of systems. Typically not tied back to anything. They are simple standalone systems. They don't need to be tied back. I don't need to tie that to a relay panel because I don't need to worry about timeout. I've got a timeout feature built in, right? So it would be redundant control if I did it. Very simplest of systems. The second system, the system that's most common now, and this is just, some people call this a peanut panel, it's an 8 relay panel. This lets me take that 20 amp circuit and start breaking it down. Right, so I've got a 20 amp circuit that fed, whatever, 4 classrooms. And I've got A/B switching or whatever I've got going on in the classrooms. I can break that circuit down now into switch legs because really if you think about the switch, the relay, it's just another switch. Okay, same as breaking down a line voltage to a line voltage switch, now you're just breaking it down into a low voltage switch. Same exact scenario. But I can break that 20 amp circuit down as many times as I want or need to. I can have one 20 amp circuit in here and break it down 4, 5, 6 different ways if I chose. Right, and that's really not unusual because if we were going to gut this thing and do it all over again, we would have these switched separately from those. We'd probably have daylight controls for the, if we had windows, more windows, we'd add daylight control to the outside edge, right? And we could create all those scenarios by breaking down the simple 20 amp circuit, okay? What we've done, so that one of the really, sounds simple, but it was maybe not as simple as some people wanted it to be. Contractors for years and years and years did their exterior lighting with a lighting contactor and an exterior photocell and a time clock. Okay? They had a 4-pole lighting contactor or an 8-pole lighting contactor, and that was their scenario. So they ended up with 3 different chunks of steel hanging on the wall. This replaces all of that. So the simplest, if I was going to do nothing else in that building except control the exterior lighting, I can do the exact same thing that you're doing with the contactor here. So a couple of benefits. In a 4-pole lighting contactor, if one pole fails, you lose all 4 poles, right? And you have to change all 4 poles, and they're dead until you do. In a relay panel, if you lose a relay, you lose relay. You don't lose all 4 legs. What that lets me do in an exterior situation like that is break down signage, exterior parking lot versus building mount, right? We can break it down any way we want to, and by using a relay panel instead of something as simple as a time clock, I can have all kinds of different things, trip lights on and off. I can go astro on off, I can go astro on, timer off. If I want the parking lot off at midnight but on at dusk, I can just set the astro settings, tell it where I'm at physically. It knows latitude and longitude. You just type in the name of the city you're in. It knows latitude and longitude, so it always tracks you through the year, right? So you'll go on at dusk and then off by whatever I want it to go off. I can have it go off by daylight, I can have it go off by time, and I can do different things with each of those. So maybe I want the signage on all night, and I want the building mounted on all night, but I want the parking lot off at midnight. It's really a simple process to do. It helps the owner break all that down from a cost standpoint. As controls become a bigger and bigger deal for utilities, they're mandating, California has a Title 24. Have you guys been exposed to that at all? Okay. Title 24 is probably the most, we can call it restrictive if we wanted to. California has the strictest energy control laws in the country, and they adopt far in advance of the rest of the country because their utility rates are unbelievable, right? They have demand rates in California. Depending on where you are, you can actually pay demand rates in California, even on a residential level, like 60, 70, 80 cents a kilowatt hour, right? Versus our 8.5, right? So in order to encourage you to not burn a whole lot of energy during the daytime, you can actually, California, you can buy a meter that tells you real time. Exactly where you are. You can hang a meter on your wall at your house, and it'll tell you exactly how much your house is costing you right this second, right? Will it encourage you to not run a dryer during the daytime, run it at night in the off-peak, right? All of those different things. From a commercial standpoint, Title 24 mandates that you do certain things. The newly adopted in California is that we have to turn the parking lot lighting, we have to cut the lighting in half at curfew or 2 hours after close of business, whichever happens first. If we did that in the old way with a lighting contactor, you'd be pulling wires till the cows come home, right? With a relay system, I can make that switch happen any way I want to, number one. And number two, with the relay system, I can program it so that I'm switching alternate fixtures alternate nights. Okay, that's important from a design standpoint, because if I'm switching alternate fixtures alternate nights, if I've got we won't even talk about LED. I've got an HID source that has a 20,000 hour rated lamp life, right? If I keep switching the same one off every night, which one am I going to change, right? I'll always have to go to that pole, because that's the pole that I don't switch off, right? With a relay system, it's really simple. You pull an extra wire out to each pole, and now I can switch the two fixtures on that pole individually. I can program one for Monday night and the second one for Tuesday. So relays let us break, and it's really about just breaking circuits down. It's not unusual to look at a relay panel schedule and have circuit number 1 be tied to 2, 3, 4, 5, 6 relays. Okay, just like we're breaking down this classroom. So when you think about how you're going to strategically how you're going to build that building and how you're going to wire it, because as we were talking earlier, if you don't do it right the first time, the odds of somebody going back and retrofitting it into something that's more functional, number one, it's crazy expensive, right? And so then it's just probably not going to get done. And they're going to have a wall of shame. It's usually they'll just pull down some low line voltage switches, and then you end up with a wall of shame, right? You got an 8-gain box back there hiding someplace with all kinds of switch stations in it. It doesn't make any sense architecturally. It doesn't make any sense. I mean, we can go up to 4 buttons and a station. So I can do in a 1-gang box what you would have done in a 4-gang box. Put a 2-gang box up. Now I've just replaced an 8-gang box. Architecturally, it makes a whole lot more sense to not have that great big. Do they have the wall of shame over there? Sure they do. Yeah, that's what we call a wall of shame, right? There isn't any reason to do that anymore. So programmability, again, as the simplest system. Anybody still using a BlackBerry? Believe it or not, at the cutting edge when this stuff came out, this screen is the same size as the old BlackBerry screens. On purpose, it was intended to look like a BlackBerry screen. The programmability is quite similar to the programmability off of a phone. All that design was intentional, because nobody ever thought that the smartphone was going to be as smart as it is. So the head end of this, from a controllability standpoint, this lets me program each and every relay and do whatever I want. It also lets me incorporate back to the occupancy sensor, or daylight sensor, or holiday schedules. Every U.S. holiday is built into this. Leap year is built into it. I can edit those holiday schedules. I can have the holiday schedule be different than what I want it to be. I can set it to do something on the first Tuesday of every month if that's an important day for that piece of business, right? Or every Tuesday, which would be different than the regular schedule. So it lets me now we broke the circuit down. Now we've taken that circuit and we broke it down even farther so that it's more usable for the owner. At the end of the day, when the contractor's done contracting, in this small panel, most of the time it's contractor programming. It's a very intuitive panel. It's intended to be finger friendly, intended for people to come up and push buttons and make things happen. At the end of the day, when they're done with it, um, our real goal is to have the owner not have to do anything, right? They don't usually spend a lot of time programming things. So if they have to get in here, they certainly can. The instructions are online. There's help screens right on here. You can just hit the help button any place in programming. It knows where you are, so it'll bring it up and say, what is it that you're really trying to do? It'll ask you an intuitive question. You know, what are you trying to do? And and then you can answer its question, and it'll tell you exactly how to get that done. So again, it's about breaking those relays down, breaking those circuits down to usable, user-friendly applications. And the whole goal, the entire purpose of these relay systems is to save energy. Okay? If we don't do this and design this to save energy, and it doesn't get utilized to save energy, then it becomes a useless device. It hangs on the wall and doesn't get utilized. I'm a huge fan of the local low voltage switch when I'm using a relay panel. It's great if I can, maybe your corridor is always on, right? But maybe it's not, and it doesn't make sense. We can incorporate any kind of switch you want, whether it's a push button switch or a keyed switch or what have you. I've always looked at any design that we do that the person that's occupying the space needs to be able to turn his lights on and off. They just do, or a lot of stuff's not going to get done. If that corridor was on a timer schedule and the cleaning crew comes in at 11 o'clock every night, so we leave the lights on until midnight, and one night they're jacked up because of weather or whatever, and they get in at midnight and the lights are off, and there's no way to turn the lights back on, just don't do the work, right? So utilizing local low voltage switches every place that you can break it down just makes a ton of sense. It makes it a lot friendlier to the end user, particularly in school settings, things like that, where they do keep odd hours. So override it. We can build a flick horn in. So Chad's down here burning the midnight oil, correcting everything. It's 11:30 at night, and we're going to have an off sweep at 11:30. At 11:25, the lights will flick. Just once. They flick, and they tell Chad that in 5 minutes the lights are going to go off. Okay. It's called a flick horn. Chad walks over to the wall, he pushes the button on the switch, and it tells the system, hey, I'm in here, leave the lights on until the next off sweep, and whatever the next off sweep is. We can program an off sweep every 2 hours, right? We can program maybe half hour. We can program any time you want it. Typically, the step is about 2 hours. That may sound like a not very smart feature, but that's not necessarily true either, because there are a lot of relay systems that aren't able to recognize that flick, right? So they'll have a flick horn, but in order for the relay system to know the state of the relay, it has to turn everything on and then turn everything off that you want off, right? Imagine what that looks like from the outside of the building. At midnight, all the lights turn on for 5 minutes, and then 80% of them turn off. Again, back to the ballast issue, right? We'd have to use a program start ballast in all of those light fixtures, because we know we're going to be flicking lights on and off at all kinds of weird hours. The ballast is more expensive. There isn't really a reason for it. Flick horn's a very important part. What else should we hide in here? Holiday schedule, low voltage switches, occupancy sensors, daylight sensors. We can program this and tell it which is supposed to have take precedence, right? So I've got a daylight sensor pointing towards that window. I can calibrate this so that I know when this is seeing 100-foot candles, I want to switch off the exterior row. I can override that and have a precedent. Who's the strongest arm in the room? Which guy makes the most sense? And you can tell the relay panel who takes precedence, whether it's an override by local switch, or it's the occupancy sensor, or it's the daylight sensor. You can have it be smart enough to know the difference between. So that's all great. That's all simple onboard control. The next step in this type of system is to put a web browser, right? I've got multiple panels in multiple buildings. We've done the entire campus. Does it make sense to go to each individual relay panel? No. We can gang relay panels together, so maybe I tie a whole building together, and I have one port of entry, right? And I've got 3 different buildings, so I've got an IP address for building A, building B, building C, building D. What that lets me do is remotely through the web, just log on to that address, and now I can see every single relay in the entire building, and I can do it from the comfort of my house, right? I can do it from my smartphone. You can probably do it from a BlackBerry, but it'd be a lot of bushes. campus-wide control. So simple onboard, a series of button pushes, overrides that. You can override any of these relays. I can, it's a different panel than I'm used to, but I can override these relays and turn them on and off at the relay if I chose. Okay. Simple onboard, I can go to a web-based system. That's all pretty neat. That's actually probably the most common sort of control right now that we do. Certainly any architectural building that we're doing ends up going that route. These little peanut panels are great for small retail applications, right? I've got a little retail store with 6 or 8 circuits that I want to break down. I can use an 8 relay. I can put a slave pack. I can have 2 16s. I can go up to 32 relays on a simple system like this. On a web-based system, I can put as many relays on it as I want, right? 48 relay panels and just stack them up, and I can put 10, 12 panels on that system and control the entire thing from a laptop. That's the most common. The next step, and where the industry is going to go, because we really want that capability, is a full web-based system. This is exactly what it looks like. It's, if I have my glasses on, I can see that. It's just a router, right? So I've got a wireless interface. I've got a wireless interface now. So I brought the internet to my router. And this lives on the site. I don't have that anyplace anymore. We get rid of the relay panel entirely. That's it. It doesn't exist. I don't need the architecture. I don't need to find an account. We're going to hide that in. Okay. I've got a wireless router, so I bring the internet into my router. It's got its own IP address, and then I use all kinds of neat things like. Actually, I don't have that many things because it breaks down quite simply. We call it a butter stick. This is a wireless relay. It wires to the fixture, of course. It has an antenna on this side for fixture control. No direct connection between this and the router. No connection between this and anything. Just the light fixture it's controlling. This would typically live right inside the light fixture. So if I was going to do maybe a linear run of fluorescent, an indirect type pendant mount fixture, I could put this in each row, and now I can control that entire row from this without adding any wire. Okay. This is the ultimate, and I can break it down. Personally, this goes to me. This goes a little bit far. It isn't very often that in this classroom I need to address each and every balance and each and every fixture independently. Right? I mean, it's cool that you can, but let's face it, it's an awful lot of cost. This is about a $150 device. Okay. So for $150 a piece, am I going to ever recoup an energy savings by being able to switch every fixture independently? It has a real neat cool factor, and you see it in some very high-end, some Class A office space. You might see people breaking down that far. It's pretty unusual. This guy is also a $150 device. This guy lets me take up to a full circuit. So while this is per fixture control, this is per circuit control. Okay. So again, same scenario, and the ports are so that I can drop down to a local switch. This connection is a hardwired connection. Okay, from this device to this switch, but the controllability is still all done wirelessly. So this guy lives up in the ceiling. There's a port for an antenna on it. The one drawback is that they all do need to have an antenna, right? They all do need to be able to see each other. It's a mesh network, a self-healing mesh network. So if a device failed, if this failed, or if this failed, it's a device. They're used as repeaters. Right, so I've got one here, I've got one in the next room, one across the hall. If one of those devices fails, the other devices see it. They all have independent IP addresses, so they all know what they're supposed to do. So I can send a command, and it might run through 100 different devices before the device that I'm talking to does something. Does that make sense? Okay. So the ultimate in being able to break it down. It's a terrific retrofit application. We're doing more and more of this in retrofits. Remember I said it's to go back to a system like this that's hardwired, where I've got to pull wires through ceilings, across condos, existing condos, all that other stuff. This changes that game entirely, because now I can go into that building and without adding any wire, I can have complete controllability. We talked about exterior lighting. That's the exact same form factor as a photocell that goes on. I didn't even notice if the lights out here are on a photocell or a contactor, but whatever. If you have a photocell on an existing light fixture on a pole, or a photocell on the outside of your building tied to that lighting contactor we were talking about before, this is the exact form factor, it's the same unit configuration on the bottom. So you take out your photocell and this guy plugs right in. And now that pole in the parking lot that's 400 feet away is part of my mesh network, and I can control that fixture the same way that I would control the fluorescent fixture right here. And breaks the whole thing down. This is a big, big deal, especially as people are going to have to be compliant. I mentioned California's Title 24. Title 24 is actually almost the exact verbiage that the new ASH rate 2010 has. We haven't enacted 2010 here in Minnesota yet, which is interesting because I think 2012 is supposed to be out shortly. There's always a couple year lag as we bring those things forward. And in reality, there's no governing body that, even if we are using ASH rate 2005, I think that's the one that Minnesota is using now. There's no enforcing body that comes around and goes through your lighting plans to make sure that you're compliant. Firms are compliant because they know it's a best practice, but no, there isn't a governing body that comes around and makes you submit all those. Wisconsin tried it for years. They tried to have a governing body that was going to review every set of lighting, every set of plans that came out, and it ground the entire system to a halt, because if you imagine the quantity of people designing systems and the whole thing funneling through a couple of guys at the state, nothing against state workers, but really, how is that going to work? It didn't work well. So that's not going to happen, but professional design firms, whether it's a Machado or a Dunham or whoever, pick any of the design firms in town, they already have standards in place that are pretty compliant with those standards. It's part of the reason that LEED has fallen off. LEED requirements, you guys all familiar with LEED? You've heard this, right? LEED's requirements already fit most engineering firms' standard practices. So the cost of having a building LEED certified can be prohibitive, particularly since you now have to recertify your building. And as a LEED professional, you have to continue getting recertified as a LEED professional. There's a whole lot of cost built into it to really design to the standard that you're already using anyhow. So, but to be compliant with some of those things, this device is a whole lot easier. Now my existing building, my existing stuff in the parking lot can all be controlled without pulling another wire. And I'm pretty sure that pipe that's been out there for, God knows, 20 years, and I'm going to try to jam a couple extra wires in so I can break that circuit down, because there's one circuit or one switch drop from that pole all the way back to the lighting panel. You're not going to get another wire in that conduit. I can just about guarantee you're not going to get a wire on. No, we don't need to. We can add this on. And actually, it's even simple. Even if there isn't a photocell on the pole, we can add a photocell to the fixture. Right? Most shoeboxes have a glossing built into the top of the housing that you can knock out, put a photocell receptacle in, and then add this device to the top. Still a whole lot cheaper than trying to pull that additional conduit. We could do the same thing with this guy. We could intercept it in the base of the pole and put this guy in the handhole. I'm going to put to the top of the pole. Right? This guy could sit inside the handhole of the pole, and if it's a single fixture, if there's two fixtures up there and I want to break it down, I might have to pull that extra switch drop down from the top of the pole, but just to the handhole, right? And add two butter sticks to it, and now I can switch them independently. Each one of these is a base.
What's the voltage and current limit on these? The one that breaks the circuit and the one that breaks the circuit?
They're 120 to 277, 10 amps.
Okay.
Okay. Okay. So
you can do a lot of damage with it.
Exactly. Most design firms, this guy is two 10 amp circuits. Okay, so I can handle two 10 amp loads. I can't handle a full 20 amp rated or 16 amp load. I can't handle the whole load off of this. I would have to break it down once. Okay. It's pretty unusual to find a lighting load that's all the way up to 16 amps. Most design firms, when you talk to their designers, they don't like to load a lighting, design a lighting circuit independently that's typically higher than about 10 amps anyhow. 10, 12 is really on the outside edge for a lot of those guys. They certainly don't push them up to 16. Okay.
That's what we do too. That's when we came up with the 18 fixtures per circuit there. That's a Same concept.
So you're at about 10?
When we do 18, if you add it, we're hovering around 10, if not less than that.
Yeah, and that's pretty typical. That's where most folks are. There are some inherent reasons to stay away from pushing up to 16 amps. I'm sure Chad's covered these, but a lot of HID fixtures have a higher open circuit amperage than they do starting and operating amps. And open circuits would be, an open circuit to that light fixture would be a hot restrike condition, right? So you accidentally turn the lights on and you turn it back on. A lot of the times, those HID fixtures will draw double in a hot restrike. So now you've got a 10 amp circuit and you go into a hot restrike situation, it's going to draw a full 20, and really you'd be ready to the whole thing to 16 already, right? So you have to be aware of those things. That's why a lot of these devices would it handle a 20 amp surge? Certainly it would, a momentary, right? The problem with a restrike, and especially a hot restrike in an HID, is that that's not momentary. That's not just an inrush, it's a sustained current, and that sustained current's going to trip out load kick through it. So you have to look at inrush from switching gears a little bit. We've talked about fluorescent and HID, but the lighting of the future is LED. There's absolutely no question about it. Not every fixture, not every project can handle the cost delta of an LED fixture, but that doesn't change the fact that they're all going to be LED. That there's no question about it. We can change these out to LED right now, have full controllability with the driver that's in it. Right now, these are switched on and off. For about $100 fixture delta, we can make that fixture an LED fixture and put a 0 to 10 volt controller in. So that driver will handle line voltage. If you're just going to switch it, it's got 0 to 10 capability built right into it. So I can tie that fixture directly to a daylight sensor or a dimmer on a wall and do whatever I want to with it. If you were going to do that with a fluorescent fixture, you would take that same light fixture, change out the balance to a 0 to 10 volt dimmable balance. The 0 to 10 volt balance costs about $100. So if you're controlling a fluorescent fixture at all right now, the difference in cost between the fluorescent fixture and its LED replacement is a push. And LED it's not the answer all to everything, right? But it certainly solves an awful lot of problems. One of the things to think about when dealing with LED, there's two phenomena in the LED. One is inrush, and you need to know that. Not every manufacturer publishes it, so you kind of, since they don't publish it, you got to dig pretty deep to find it. But there is an inherent inrush in LED that has to be accounted for, similar to the inrush that you would do with an HID, right? And you could probably safely size to 10 amps, but depending on the fixture and the driver and all the other parts of it, you should be aware that of that inrush and that it's part of the process. The other thing that almost nobody's talking about on the LED side is harmonics. And harmonics kind of went away. It was a big buzz for a long time. Fluorescent balance had horrible harmonics, 20%. Harmonic distortion, we were causing all kinds of problems. You were doing all kinds of problems with your white boards, your smart boards and stuff. Most balance now run at about a 10% PhD, less than 10% total harmonic distortion. Not every LED driver does at this point, and it's interesting because the industry hasn't clamped on that yet, because it's going to need to be addressed as they get more and more involved in the business. It's going to be a bigger deal. Our business right now, just from a lighting standpoint, is probably running 30% of every light fixture, of all the light fixtures we sell are LED based. We're ahead of the national curve by about 10%. Nationally, it's about 20%. This market's a little higher at about 30%. And predictions are by 2015, it'll be 80%. So all important things that you need to be looking at and considering all the way back to breaking down that lighting circuit. What are we going to do with it? How do we want to control it? Are we going to dim it? Are we not going to dim it? Switch it, local switch it, time clock, daylight, all of those things. So that's kind of a really fast overview. Maybe because I've talked about this so many times here, Chad, I kind of run through some stuff faster than I should. Do you have any questions on any of it?
those wireless ballasts or whatever, they're in concern with like hacking. Someone can break in and turn off all the lights at the U of M or something like that.
Yes, there is concern. This system is built around a mil-spec system, so this guy actually changes its address every fraction of a second. It's nearly impossible to hack. We did all the controls at the Twin Stadium. So literally at the Twin Stadium, I could, through my smartphone, get into their website and turn the lights off in the middle of a really bad game. Like a Buffalo Wild Wings commercial. Yeah, just the night games, can't anything about the day games. So yeah, there is a concern. Most folks that are dealing with a wireless system and a web-based system are using a mil-spec protocol so that we continually change that IP address externally.
No concern about signal loss or anything between the two? Like, I lose signals. I got a wireless, I lose signal. Seems like every day.
That's the purpose for the mesh network. When you go to a mesh network, the way this one is designed, yeah, this doesn't do a great job of talking through it. If you pop onto HubbleLightingControls.com or Hubble Building Automation's website, they'll talk more in depth about how that wireless mesh network works. So whether I've got obstructions, but it's a point, because in a building like this that's an awful lot of block and steel, you have to be aware, right? In clear line of sight, if I have line of sight antenna to antenna on an exterior, they've actually played with this down. We can get over a half mile away from this guy to this guy, or from this guy to the light fixture. We can be a half mile in distance if we have clear line of sight, no obstruction. You could potentially run into issues in a building like this where I'm all block and steel and I don't have that line of sight. The key would be to make sure that these are positioned close to the next abutting wall, right? Any demising wall or anything, I just need to be next to it so that I can get through and around and over and whatever. But if I've got this device in this room and another in that room, and I've got one in the hallway, the one in the hallway will repeat what I'm sending and bounce it back and forth. So 100 different devices or 1,000 different devices, it doesn't really matter. All of them see the signal, right? They see an on command for butterstick number 93. They all see it. They just all know they're not butterstick 93, so they don't do anything. But they're going to keep repeating it until 93 sees it and does its thing. So that's the point of a self-healing mesh network.
I don't know, Keith, if you, I was out a little bit, if you talked about the interface between this one and security panel and building automation system and fire alarm system, and you can mention something.
No, we didn't go into depth with any of these. That's actually very common. It isn't unusual to see it written in the specification that we need to be able to talk to the building management system. Interestingly enough, we never know who that is, and it might be true here. It certainly is true out in the world. Mechanical departments and electrical departments in the same design firm don't talk to each other. They just put them on different floors, put them in different buildings, because they don't interface at all. So we never know who we're going to get. So we have to build different protocols to be able to handle it. BACnet is probably the most common building management language. LawnWorks is certainly out there, and is a very viable language as well. But you have Honeywell has an interface, Johnson Controls has an interface, Johnson has different interfaces, whether it's their Metasys system or a standard system, and so you have to be able to talk to all of those. It's most common if you're not. We can handle both BACnet and LawnWorks directly, so I can just take their contact closures right into my panel, and their system can now see my system. They can see what every relay is doing. If the system coming in isn't BACnet or LAN, we just supply what's called a gateway. And the gateway takes my language into one port, and their language into another port, and turns into a translator. And it literally is, it's about that big, and it's a hard drive. It's just a hard drive that converts to two languages. Most of the time what building management people want to see it from a lighting control panel. They're not necessarily overly interested in changing our programs. They really just want to be able to monitor to see what is on and what is off. Okay. We have inherent smarts in here that will tell us if I have false tripping or nuisance tripping or what have you. We have inherent software here that lets us go back to any individual relay and mine back as far as we want every action. So and it's you run into funny situations. We did a school, and they were telling us that we were somehow false tripping and turning the lights on in a secondary corridor every night. And when the lights turned on, the light itself triggered a security alarm, because the security alarm saw the light as motion, and when it saw it as motion, it called the cops, and the cops kept coming out to the school, and then they boiled it all down and said, it's you guys, it's us turning the lights on when they're not supposed to be on. We must have an inherent problem in our system. But because we could mine backwards through the panel and see exactly what's going on, what tripped it, it was tripped by a motion detector. Motion detector has to see passive infrared, right? So it needs to know that PIR is body heat, right? You could roll a bowling ball down that corridor and it's not going to see that as motion because the bowling ball doesn't have any body heat. So when we knew it was a motion sensor that was turning everything on, we thought maybe they should talk to their people. And it turned out that one of the custodians used that exit to go out and have a smoke every night about 11 o'clock. And when the system saw him, the system saw him turn the lights on. When the lights turned on, the security system saw the lights, thought that the lights were motion. So there must be a body there. Turned into a whole big damn deal. It was a big meeting, and it just really turned out the security guy should go to a different door and smoke. Heading out the wrong side. And believe me, that's a big part of what we do is that type of interface with the owner. The other thing that we know from doing this for so long is that the spec as it gets written and the panel schedules and the timing, all that stuff gets really well thought out by the designer, by the engineer. Everybody mines through that whole thing and they come up with what they think is the best use of that building. The only person that knows how the building is really going to work is the owner. Right? I mean, we can think all we want, but unless you live in the building, you don't know. Unfortunately, for the owner, when we go into a startup, it's usually at the point of occupancy, right? They've got an occupancy permit. They're opening the doors on Tuesday. The week before, everybody's there. Security guys, mechanical guys, lighting guys, everybody's, and literally sometimes you're stacked up in the hallway waiting for your turn, right? You can only absorb so much, and when you're on your third, the telephone guy is there. When you're on your third or fourth or fifth system, you're never going to know what else going on. You just aren't, right? The great thing about the web-based systems is two things. When asked, and more design firms are doing this, they actually have 2 owner training sessions built in. One at point of occupancy, and then one scheduled 6 months later, right? Because they didn't remember anything we talked about that first day. We just got the building up and running, right? That's the purpose for the local switches. Get the building up and running, let them move in and live there. After about 6 months, they start to realize this works, this doesn't work, right? You know, in a hardwired system like this, we would come back, do that second set of owner training, and then override everything, change all the timer schedules, change all the interfaces. We would mine through that whole thing and set it up the way if they want it. The web-based system is so much nicer. I don't have to go to Baudet to do that because it's web-based. After 6 months, when they've decided what they want to do, they grant us access. Typically, they give us a 24-hour access. We log in through our website or log into their website and go right into their relay panels. We can do it real time. They can watch while we're doing it, so we can program on our side. They can watch what we're doing on their side, and completely change all the programming from the comfort of our own home or Vancouver or wherever the tech is that's doing the training that day. And believe me, that saves a whole bunch of money. For us to bring a tech out, typically to do an owner startup is about a $2,500 first day, $1,500 a day thereafter. So if we have to do a 2 or 3 day startup, that owner can be looking $5,000, $6,000, $7,000.
How much your system costs?
Hardwired systems, if you think about it, just call it point of control. A hardwired system, say with a web browser built in, so this kind of guy, not a wireless guy, this guy with a web browser built in is you're probably looking at $150 to $200 per relay. And that's a broad budget number, but that budget number includes the web interface, it includes local switches, typically aux sensors, unless you're really loading it up. I mean, if there's, for some reason, there's 3 occupancy sensors in a space and daylight sensing, all that stuff, then the number can get out of hand. But at about $150 a relay, or for point of control, we'd call it.
On startup, do you guys monitor the system, say, for the first week or something? Or any, do you have any issues?
No, no, because you can run through, again, in a hardwired system like this, you can run through the programming. Every program you have in, you can do, and actually we have an accelerator in here. So we can set up a program, and then we can do we can run in 30 seconds. We can run a full week's worth of programming, right? Not switching, right? But we're running the entire program, everything that's on relay number 1 for a whole week. So we can sit and monitor the screen and know every action that we have programmed in. Sometimes there is a hidden action in there someplace. Somebody's gone in and they've added something and didn't know how to get out, right? And then you do get a false on or a false off in the middle of the day. Someone will add an off sweep at a time and not know how to take it out. But that goes back to being able to go into here and see last action, or see all the actions, right? So if Chad says, keep the lights in my classroom turn on every day at 11 o'clock, every single stinking day, and I go back and we override the switch and they come on, and then the next, we can go back and monitor that and look at it and say, well, there's somehow somebody was playing with the damn system and put an off sweep in where it didn't belong.
Like you said, Keith, it boils down to training the customers how to use the technology. Really is.
It really is, and there was a point in time where we were really over designing to the customer, because people just didn't have that much electronics. I mean, some of the first projects that we did, we would load the program onto a disk and then bring the disk out and slide the floppy disk in. That was awesome, right? Make a change, mail it to Baudette, and hope they install it. But as those maintenance electricians, and that's typically who ends up having to carry this, right? This ends up, if the building has a maintenance electrician, or it's the electrician that they hire. Sometimes the school doesn't have either, and it ends up being, the art teacher, right, or the music teacher, or whoever didn't say no, right, ends up having to live and own this thing. That becomes real difficult for us. And back in the old days, when we first started doing this, that was a real problem because they didn't have a very high level of sophistication. So you'd always try to dumb the system down. We really don't find that anymore. It really doesn't matter where we are. Pick the smallest town, the biggest city. Most folks are pretty technologically savvy these days, right? And with a little bit of training, they can figure it out. The controls have also gotten a lot smarter. Again, not just, I represent 2 different lines of lighting control. Building Automation is out of Austin, Texas, and Douglas Lighting Controls is out of Vancouver, British Columbia. And there are probably 8 really big lighting control firms doing business in the North American market right now. We represent 2 because we couldn't get a third. No, we represent 2 because they do different things, and they take different approaches to it. And not every job fits every manufacturer. Building Automation, while they use a robust relay, they don't use the relay that I like. Douglas uses an Aeromat molded case relay. It looks like a 20 amp circuit breaker. It's built to Canadian standards, so it's rated at a full 20 amps at 347 volts, right? It's a big, beefy beast, right? with a toggle on it, I can toggle that relay on and off. If it's on, it's on. If it's off, it's off, and the button says so, just like a circuit breaker. It can't be, it can't say on and be off. It can't, right? It's a mechanically latching relay, not an electrically held relay. Most lighting manufacturers these days, it's another good point. People do use electrically held relays. That's an inherently bad situation because its failure then is to open, right? If there was a power outing, or power outage, an electrically held relay fails to open all the time. So power to the panel glitched for whatever reason, power came back on, everything fails to open all the lights off. Mechanically latching relays are always in their last state. So that same power interruption on a latching relay, power interruption, that light's off, that light's on. When the power comes back, that light's off, that light's on. It can't not be. So from a safety standpoint, that's the safest relay. And I can tell you in all these years of dealing with Douglas, I don't think we've had 4 or 5 relays fail, literally out of tens of thousands that we have on the board. Who else? We talked about the relays. GE, who's a massive worldwide company, still does business in lighting controls. And after all of these years, they finally adopted a version of that Aeromat style relay. But for years and years, they had the RR7 relay. Chet, you're familiar with it. Most of you guys, if you know what I'm talking about. RR7 relay was a barrel that had 2 contact points on it, and you literally wrapped a lead around it. And it was a relay. It opened and closed, and you sent it a signal, and it did what it was supposed to do. But you had no idea what state it was. You could look at it, and all you saw was this cylinder, and there was nothing on it that told you anything was going on. So the only way to really know if you said I want to turn relay 7 on, the only way to know if relay 7 was on was to go look at its associated load and see if it was really on. And that was lighting control in the beginning. That's what they did, and people thought that it had arrived. And certain people still use it. St. Paul Schools uses tons and tons and tons of it. They like it. The rest of the world doesn't. So you guys incorporating this stuff in design?
Yes, we have, let me check this, dash that work here. I think, show you what, we have a 225 amp panel with a lighting control panel. I don't know if mine got out here. So we're still using the old way, probably with relays, and I don't know, did you guys have a chance to look at the relays here?
Yeah,
So,
this stuff is all you guys come up with when you're.
yeah, you feel free to come here. So we have a 225 amp panel, lighting panel feeding hopefully a control panel like this to control, what is it, 12,000 square foot commercial building with occupancy sensors, low voltage switches, and timers and parking lot lights. So that's kind of done.
Okay. Okay.
Which is Hallberg office building.
Okay, so that's Joe's office?
Joe's office and all this good stuff. So.
Okay.
So what we're doing with these right now is in Revit we will drop a lighting control panel, and then we will circuit the lighting fixtures, and then we pick low voltage switches and occupancy sensors as your switching mechanism, and we stop right there. Though Revit is capable of running a relay schedule directly from Revit.
Really?
Yeah, so we can you can have a relay schedule, you know, a relay assigned circuits and loads if you set it up right. We haven't done that, but it's capable of doing a relay. We've done very close to a full relay schedule.
Wow.
From
I'm not
panels.
seeing that. I've not seen anybody try to do that
Yeah,
outside of a setting like this. I've not seen anybody apply that to a project.
yeah,
They usually go old school and do their relay schedule the old-fashioned way.
yeah, yeah. So that's kind of where we are. We stop and then we power this. So it's really nice. Then we run the schedule, lighting schedule, and relay schedule from the panels. Do you guys any questions about lighting control panel? Is it clear now how to control the lights to a 24 volt or so
wired, wireless. We're doing wired.
Mhm.
Old technology right now. You guys are going to be doing with us a panel like this, wired with occupancy sensor, low voltage switches, timers, and so forth, and we move from there.
They've used that GER7 relay forever, right?
What is the solar GX for the same thing? I know that because we did a job at summer, they had to control the lights, two gyms, and that's what they wanted, was solar GX. I don't know well, did it, but, we installed it, control the lights. I don't know if that's still the same thing.
That's interesting. I don't know what that is. Was it from GE?
Can't remember. Try to look it up.
I'm not familiar with. I don't know what a Solar GX is. That might just be an interface between what they're doing. They've in some of their schools they've adopted some of the newer technology. But I'm gonna tell you that probably 80% of the schools over there still use that old style barrel relay. I don't remember the gentleman's name that ran all the electrical maintenance over there. They had one guy and right, wrong, or whatever, that was the system he was comfortable with. And he didn't want different systems in different schools, so for the district, he did the right thing and put the same system in all of them. Maybe to a fault, because at some point the system got surpassed in technology by other people, and they didn't try to stay with it.
So this is my sketches, and I know you're going to correct me. So here's your power 225 amp panel, bringing the circuits to a conduit into your light control panel, getting your 24 volt to power it, and then multiple relays with the low voltage side, low voltage switch occupancy sensor turning the switches off, on and off, powering the coils. Then the contacts controlling. We have 18 fixtures here on one circuit, one relay, and another 16 fixture on one relay. And then we showed in the circuit, relay schedule, circuit, relay, and location, some type of a combination.
Yeah, so that's what I was talking about before. You got circuit one in two different rooms on two different relays.
Yeah, and that's what I was emphasizing. So confusing for a lot of students to understand from my experiences. They think every circuit has to have every switch that a circuit and switch is the same thing. It's not. You can have a circuit power multiple location with multiple occupancy sensor controlling these location or multiple switches. So
Exactly. Well, and it just makes sense because that 277 on a 20 amp circuit.
you can put,
Yeah, I don't know how many classrooms can you get on it? 3?
yeah, you can put a lot of lights.
Yeah.
We did calculation on we don't use 277 in this project, 120. But you can put close to, depending on the what, close to 80 fixtures on a 277 20 amp circuit. Not like you want to load it that much.
Yeah,
But you can put a lot of fixtures with LED, especially a lot of fixtures.
Well, you finally got it right, Chad.
Yeah. So that's what I was trying to kind of get him, because people and the controller that you were just talking about here, interface, communication interface, power 24 volt for the most part. Then this is a brain. You can do anything you want to do with it.
Exactly.
Right, the mic. And I told them this is where you guys the guts. You talk about it. So it's so that's what we're trying to achieve.
Yeah, that's a big moving target. A building designed without and a building designed with, and they're very subjective numbers depending on who you actually. DOE, the Department of Energy's website, I think the DOE says about a 40% energy savings by putting a simple relay panel in versus not having any control. No, there are certain places that are just inherently smart, right? Stairwells. Stairwells in most buildings are occupied something less than 3% of the time that the building is occupied. So it's a natural target for load shedding. Right? And the thing about load shedding is that utilities have to rebate. I mean, everybody understands that, right? Xcel Energy has to issue so many dollars in rebates based on their income that year, right? So if they bill X, they've got to rebate a percentage of X every year, or they get fined. So it's a big deal. So they're constantly trying to find ways to fund these. Now, while they won't fund a lighting control panel, they'll fund the energy saving products, right? So they won't give the end user money to add this as an after. So we have to add that in conjunction with whatever fixtures but they will, see, they don't quite get, they don't get it either, and there's nobody really trying to work with them because it's just, it's government bureaucracy, and it would be a labor of love. Nobody's gonna get paid enough money to do it. They will rebate an occupancy sensor, but they won't necessarily rebate a relay panel.
Any comments, guys? Any questions about lighting? We're good, ready to lay out lights and circuit and control and all this good stuff?
So I'll leave some literature
Yeah,
behind
thank
for
you,
you
Keith.
guys.
You have the
There's literature here regarding this panel, this little CX panel. There is some literature here for the wireless system if you want to take it just as an interesting read. You're going to see more and more of this. We'd probably bid, right now, probably 30% of the projects that we're doing have some version of a wireless system loaded into them. So there's no question, just like the LED is the future in lighting, wireless is the future in low voltage control. It really is. It makes too much sense from an economic standpoint. And actually, a lot of times a wireless system can cost less, not just in purchase cost, but certainly from an install cost than a hardwired system. Hardwired system has an awful lot of labor in it. We're not trying to take any more labor out of this country because we've lost them all already. But if this is $100 per point of control, $150 per point of control, that's what I said this butter strip is worth. So if this costs as much as a relay in here, and this goes out in space with no wires to it, and this I've got to run a wire from here to wherever the load is, which at the end of the day costs less money.
Well, thank you, Keith.
You guys want to kick the tires on the stuff?
Yeah, if you guys want to swing by and just look at that, that would be great. Thank you.